we are on 3-3 linear programming today. Today is just like the last couple of days. We're going to be graphing things. We're going to be finding the vertices where they intersect. And there's just a couple of things that are new. The new things aren't hard either. It's just shoving it all together. Okay? So, linear programming sounds scary. It's really not that bad. Linear programming is used to find max or min values. It's actually used in the real world often to find like maximum profit and stuff like that. But in this class, I don't know that we'll get that in depth with it, but that's what it's used for typically. Constraints are the inequalities. Feasible region is the intersection of the graphs. Bounded region is when a region forms a polygon. It has a max or a min. A polygon is like a triangle, a square, a rectangle. When it's a closed shape, there's a max and a min. Okay, when it's unbounded, the region is open, so it's like missing a side of the triangle kind of a thing, or whatever shape. And so that means it has a max or a min. It does not have both. Okay, and we'll get into that later. So these first two are not story problems, so we don't have to define a variable. They already did. We don't have to write a system of inequalities. They already did. See that? System of inequalities. We have to graph them, which we know how to do, right? You should. And then we know how to find the vertices. We've already done that. You just did it on your homework quiz. You found the vertices where they crossed, intersected. Step 5, we don't have to write until it's a story problem. They write it for us. Step 6, you substitute. You know how to substitute. Step 7, max or min. So the idea is actually really easy, okay? I'm going to go to the next page because I put this on actual graph paper like you guys need to. Right here. So what we need to do is graph everything, right? So let's start with the easy one. Let's start with y is less than or equal to 6. Show me in your arm what y equals 6 looks like. It's a horizontal line, okay? Y equals 6 looks like this. Is it going to be solid or dotted? Solid. So 1, 2, 3, 4, 5, 6. I'm not going to shade just yet. I'll say y in a second. I'm also not going to label that line because I'm not going to forget what one it is, but if you want to, you can. I'm going to graph y something negative 2, okay? So go to negative 2 on your y-axis, solid line. Like I've told you before, there's multiple ways to look at these, but literally this says y is in between negative 2 and 6. So where am I going to shade? In between negative 2 and 6. Again, I don't shade on here because it's hard for me to erase it, but you could do it lightly, or you could just think about the fact that it's shaded in between. That's your decision. So that one's done, okay? Let's go ahead and graph this one since it's already in slope-intercept form. Where do I start? Up 2 on the y-axis, and then down 2, right 1, or up 2, left 1, a bunch, right? Where's this at? 1, 2, left 1 right there. Is that right? Down 2, right 1, down 2, right 1. 2, left 1, up 2. It's not in slope-intercept form, so I just skipped it for right now. We'll do it in a second. So you graph that line. I am going to go ahead and label it y less than or equal to negative 2x plus 2. Okay? Just in case later I need that. I don't know if I need it or not, but it couldn't hurt. You guys go ahead and get this one in slope-intercept form for me, please. It's not in slope-intercept form. It needs to be. Go ahead and do that. So it's going to be y less than or equal to 4/3 x plus, what, 26/3? Which is really about 8 2/3. Is everybody okay with that? So this is where it's going to get kind of hard, right? You just do the best you can. So I'm going to go up to 8 2/3. If this is 6 and this is 8 2/3-ish. I'm going to go, I could go up 4, right 3, but obviously that's not going to help me. So I'm going to go down 4 and left 3 a bunch. So down 1, 2, 3, 4, left 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Solid again. Okay. I'm going to label that one. You can label it the original or the one you messed with. I'll go ahead and label it the original. And I didn't shade as I went because, again, that's kind of hard for me to do on here. So we said at the beginning it was in between the two parallel lines. Is everybody still comfortable with that? Okay. This line here said less than or equal to, so it's going to be below it. And then this line here said less than or equal to, so it's below that one. So our answer is the triangle, the shading inside of the triangle technically. Every day before today, that would have been probably where we stopped, or we would have said the vertices and been done. Is anybody confused? We have time for questions, so if I've lost you, please say something. Is everybody caught up? You're fine? So the vertices, there's 1, 2, 3. 2 of the 3 of them are easy, and you're not guessing. Which 2? Yeah, the top one and the right one. I'm not guessing. Do you see how this was a dot on both lines? And do you see how this is a dot on both lines? I'm not guessing. This one, I don't know where that is. It didn't hit my slope. Does that make sense to you? So I can't guess because I did not use a ruler. I was not super perfect, so you don't want to guess. What if it was like 1.1 or something? I'm not going to be able to guess that, okay? So where's this one at? Where's this one? Look on yours. Count. -2, 6. Very good. Where's this one? 2, -2. We are not guessing. Does everybody understand that? This third one, we can't guess. However, I know half of it. What do I know? No. I know the -2, right? It's on the line y equals -2, isn't it? So if it crosses that line somewhere, I don't know what the x is, but I know what the y is. Does that make sense to you guys? The y had to be -2 because it crossed the line y equals -2. So I can use that information to find x. So this is the line I'm talking about. So can't I plug y in to the line, right? 3y equals 4x plus 26. Everybody can solve for, what are we looking for? X. Even if I've confused you completely, you can all solve for x. If I've lost you, ask me a question though.
Where did you use the -2 again?
So if you look, this line and this line cross somewhere, x comma y. I don't know where it crosses though. But if I'm crossing this line anywhere, y is -2. That's the equation of that line. Okay. Does that make sense? Yeah. So I know that my y is -2, but I need to plug it in to find my x. Okay? Thank you. What'd you guys get for x on that one? -8. Very good. And if you look at the graph, it looks like that's feasible. It looks like it probably was -8, -2. But what if it was -8.1, -2? I don't know that. Do you guys understand what I'm saying? Okay? So I've shown you nothing new. Right? You graphed some stuff, you shaded, you found ordered pairs. Is everybody comfortable? Okay? So this extra thing right here, where we are right now in the steps, they gave us variables, they gave us inequalities, we graphed it, we found the vertices, they gave us this function, they gave us the weird looking one. You don't graph that one, you use it later. You don't graph that one. Okay, so what we have to do is substitute the vertices into the function. That's where we are right now. So back on your notes now. You're not on the graph paper anymore probably. So back on your notes, I'm going to put those 3 ordered pairs in. -2, 6, 2, -2, and -8, -2. Is everybody okay? This is the function they gave me. Do you guys see where I just rewrote it? What do you think I'm going to do? Plug them in. What's a fancy word for that? Substitute, right? So I'm going to take -3 times -2 minus 6 times 6. And plug it in. Shout it out when you get it. -30, very good. If you don't get it, please stop me or say something, okay? And then, do you have to fill in this middle part, or is that just to kind of like help you? That's my grandma. Whoopsie. I think she made a mistake. She calls again, though. I'm going to answer, because you never know. Okay, what do you have to fill this in or no? No, you don't have to. If it helps you, great. If not, I don't really care. You can skip to the end. That's fine. So did anyone do 2, -2 yet? What'd you get? 6? Mm-hmm. And what about -8, -2? 36. Very good. Take your time and get those, please. Actually try and make sure you're getting them right. If you're not, ask me or a neighbor. So here's where we pause. Whether this is, I'm going to go back to the notes, whether this is, where's that, bounded or unbounded, we still do what we just did. We find the vertices, we plug them into the function that they gave us, okay? Is this bounded where it made a shape, a closed shape, or is this unbounded where it was like left open? This is bounded, right? So what that means is we're going to have a max and a min. We're going to have both, okay? So here's what I don't want you to think. In Algebra 1, you guys had parabolas, right? So like this had a min because it was the lowest point, right? This had a max because it was the highest point. It's not like that with a question like this. So just because this is the highest point doesn't mean it's the max necessarily. And even if that was true, which one would I pick for the min? Do you see what I'm saying? So you only find the max and min by plugging it in, like we did. So just take a wild guess. What do you think the max is here? 36, because it's the highest, right? What do you think the min is? -30. Very good. It's that easy. So again, I know it's a lot of stuff, but it's a lot of easy stuff if you do one thing at a time. You graph something, you shade, you find the vertices, you plug them in. Highest is max, lowest is min. Does that make sense? Okay? Let's try the next one. So again, I put it over here because we want to graph it on graph paper. It makes it way easier. All right? You guys go ahead and graph this top one. Let's see how that goes. Graph that top one, please. While you're doing it, I'm going to do it too. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay? You should have graphed those 2 lines. A horizontal line at y is 7 and a horizontal line at y is -3. Bless you. Is that okay? Where would I shade if I had a pencil? In between them, right? So you can super lightly, if that helps you, or you can just kind of like know that we're shading in between. Whatever works for you, okay? So now we need to graph these other 2. We have to put them in slope-intercept form. That should take us like 2 seconds. Let's put this one in slope-intercept form. What do we get? Y is greater than or equal to x minus 2. Very good. So where do I go? Down 2 on the y-axis, and then up 1, right 1, up 1, right 1, up 1, right 1, or down 1, left 1, a bunch. Because we're trying to see where these intersect, you want to be as accurate as possible. So I draw as many slope dots as possible. And that was a solid line. Where do I shade? Where do I shade? Above. So again, I'm not going to, but it's going to be in here now. Do you guys get that? Okay. Take a second and put this one in slope-intercept form, please. And you should get y less than or equal to what? -1/2 x plus 4. You can't really read that. -1/2 x plus 4. Is everybody okay with that? Did you guys get that? So you start up 4 on the y-axis, down 1, right 2, down 1, right 2. Oh, that's probably important. I'm going to stop there. Up 1, left 2, up 1, left 2, up 1, left 2. Oh, that's probably important. Did you guys get that? And where do I shade on this one? Below, right? So here is my shaded region. I want to pause. You guys ask me a question if you have something. You graph the lines, you shade. Is everybody okay? Okay. Is this bounded or unbounded? Unbounded. Do you guys understand that? This shading goes on for forever. This didn't make a closed shape. This did not make a polygon, okay? But I still have vertices, So this one, and this one. Do you guys get that? Those are easy. Those are not guesses. Those are not algebraic. Those all hit both lines one time. So what ordered pairs are those? What's this one? Negative 6, 7, right? Because the y is at 7. Okay. What is this one? Yeah, if you look at yours, it might be easier, right? That's 4, 2. And what's the last one? We already did that one. It's negative 1, negative 3. Left 1, down 3. Negative 1, negative 3. Are you guys okay? You just... Negative 6, 7? That one? Okay. What do we do now? Substitute. Plug them in. Yeah. You circled 4 of them? So the only 3 are this one where 2 lines intersect, this one where 2 lines intersect, and this one. The lines don't intersect anywhere else. They just go off like that. Okay, yeah, the top right one, the shading didn't overlap there, so we don't need that one. Okay? So we use this f of x, y function that they gave us. We substitute our x and y's in, just like the last time. What do you guys get for negative 6, 7? 135. Take your time and get there, okay? What about 4, 2? What? Negative 30. Anybody get negative 1, negative 3 yet? I know that's hard to see, but negative 15. Take your time and get those, please. Ask a question if it's not working out. Lean to a neighbor if you need some help. So if this had been a polygon, if this had been bounded, closed, what would have been our max? The 135. What would have been our min? The negative 30. However, if you go back to the rules, this was unbounded, so we're missing a max or a min. We're only going to have one. We're not going to have both. This is the only way to figure it out in this class, okay? We're going to find some test points in the shaded area. Even I don't know what to pick. Even I don't know what the answer is, okay, without doing it. So we pick some test points. When we plug it in, just like we just did, if it's higher than 135, then doesn't that mean 135 wasn't really a maximum? It was like a fake, right? If it's lower than negative 30, doesn't that mean negative 30 wasn't really a minimum? Do you understand what I'm saying? So we just pick some points and we plug them in. Okay? We're looking for something higher than this or lower than this. So I typically try, like, if I can, 0, 0. Is 0, 0 an option? Is that in the shaded portion? Yeah. So we're going to plug 0, 0 in. It takes like 2 seconds, right? I draw a squiggly line so I don't accidentally think it's one of the possible answers. It's just a check. So if you plug 0, 0 in, what do you get? 0. Okay. So is that higher than 135? No. Is it lower than negative 30? No. So we didn't do anything wrong, but it didn't help. Okay? So I'm going to go even farther. I'm going to do like negative 10, 0. Do you guys understand that negative 10, 0 is in the shaded area? Okay? So when you put negative 10, 0 in, what do you get? 120? Is that higher than 135? No. Is it lower than negative 30? No. So again, we didn't do anything wrong. It just didn't help. I'm going to keep going. I'm going to do negative 20, 0. The reason I choose 0, if I can, is because it's obviously an easy math number, right? So what do you get when you do that? 240? Everybody understand that? Is that higher than 135? So what's that mean? It means there's no max. If we're higher than what we thought the max was, it wasn't really a max. Do you understand that? So this one just has a min, which is what? Negative 30. Is that okay? So tomorrow, we'll do the story problem and we'll do this assignment in class together. If you guys have